Just finished building my LED moving headlight. I used two servos, an LED driver chip, and a Wii nunchuck, and interfaced it with the Arduino Uno. I'll be showing you what it can do, and I'll just be going into a little more details on how it works and whatnot. So, using the Wii nunchuck, you can move it forward, move to the left, move to the right, backwards. Holding down the Z key, it allows you to use the accelerometer inside the Wii nunchuck. So holding on Z, you can move it forward, move to the left, move to the right, move it back. And then if you hold down the C key or just press it, you can change different colors on top of the head. And then I'll turn off the lights and show you a little more what it looks like. So you have red, green, blue, and then using pulse width modulation you can get yellow, orange, pink, purple, cyan, and white. Basically, I got two small servos from SparkFun.com and a pan tilt bracket, and then there's two data lines which basically tell which position or degree position they should be at. I have an LED driver chip here. This is the Max 6969 by Maximic. It's a 16 channel LED driver, and here I have 5 red, green, blue common anode LEDs that are hot glued on top of a water bottle cap that's just to diffuse the LEDs. You have 5 lines coming in. You have your 5-volt ground, DN, clock, and latch enable. Your DN is where the data comes in, and then the clock cycles each time that data points get pulled in, and it basically shifts it everything in, and then the latch enable actually takes whatever shifted in and shows it on the output. So basically it's 16 different channels, so you can pull in 16 bits or 2 bytes of data into the LED driver chip, and then latch enable it, what shows on the output. So at one point, for example, if you wanted to change the different intensities, say you wanted to do 50%, for example, you would shift in 1 the first time, then 0, 1, then 0, 1, then 0, which causes it to be half as bright. In this control, you have 64 different intensities. That's just the way I program it. If you want it more or less, you can program it that way. And that's pretty much it with the pulse width modulation. Oh yeah, there's also a 1.5K resistor on top, which limits the current inside the chip to 12 milliamps across each one of those LEDs, just so you don't burn them out. Other than that, it's the Wii remote uses IC squared. This fancy adapter thing is just something I bought from fungizmos.com. You could also get it on SparkFun. It's just called a Wii nunchuck adapter. It's just so you don't have to cut the cable. Because if you cut the cable, you could plug the wires in the same way, but this is just a way that you don't have to destroy your Wii nunchuck in order to get what you need to get from the Wii nunchuck. And it basically just pulls in bytes via IC squared, and all those data points have, like, if these buttons are pressed, which position your joystick's at, the accelerometer data and everything. So pretty much it. One thing I would change if I ever went back and redid this is I would use a different LED driver chip. I would use the TLC 5940, which is a pulse width modulation LED driver chip, because every time, you can't see it on the video, but every time the Arduino accesses the Wii nunchuck, it actually is a slight delay, which causes the pulse width modulation code not to run, which you can see a slight flicker, which if I used that Texas Instrument chip, I wouldn't have that problem, because then it's running the pulse width modulation code constantly on that, so anything the Arduino is doing is not messing up that pulse width modulation code. But other than that, pretty good project, learned a lot. And that's it.